Welcome to the lecture. Today we will see the problems on per unit calculation. The one-line diagram of an unloaded power system is shown in figure. The reactance of the sections of transmission line are shown in the diagram. The generators and transformers are rated as follows. So in this single line diagram, they have given the three generators, three transformers and two transmission lines. In this single line diagram, they have mentioned the transformer connections on primary and secondary side. So the transformer 1 is on delta and star connection, and transformer 2 star and delta connection, and the transformer 3 is star neutral connections. Now, in this problem, they have given the data for generator 1, generator 2 and generator 3, and for transformer 1, 2 and 3. For generator 1, that is 20 MVA, 13.8 kilovolt, and the subtransient reactance is zero point 0.2 per unit. And for generator 2, 30 MVA, 18 kilovolt, subtransient reactance is zero point 0.2 per unit. For generator 3, 30 MVA, 20 kilovolt, subtransient reactance zero point 0.2 per unit. And for transformer 1, 20 MVA, 20 kilovolt, X double dash equal to zero point 0.2 per unit. Transformer 2, single phase units, each rated 30 MVA, 127 bar 18 kilovolt, and the reactance is 10%. Transformer 3, 5 MVA, 220 bar 22 kilovolt, and the reactance is 10%. For the given data, we have to draw the impedance diagram. For that, we have to choose the base value of 50 MVA, 30.8 kV in the circuit of generator 1. Now, we have to take the 50 MVA and 13.8 kilovolt base from the side of the generator 1. Now, in this single line diagram, they have given the three transformers. In that, the transformer 1 and transformer 3 are three-phase transformer, but the transformer 2 is three single-phase transformer is connected for three-phase operations. So, while taking transformer 2, we have to consider the connections of the transformer. Based on that, we have to go for the voltage conversion. Now, we will solve the problem. So here they have given the base value, that is MVAB base, that is MVAB new equal to 50 MVA, KVB new equal to 13.8 kilovolt. Based on this, now we are going to calculate the reactance for generator. Now, reactance of generator 1. So the formula for calculating the reactance is X per unit generator 1 is equal to X per unit volt into KVB volt divided by KVB new the whole squared into MVAB new divided by MVAB volt. So this is the formula for calculating the per unit reactance. Now, for each and every component, they have given the power rating, voltage rating and the reactance rating. So that value we have to take it as a old value. So for generator 1, here the per unit old value of the reactance is 0.2 and the KVB old is 13.8 and the KVB new is we have to consider as a new base value that to 13.8 the whole square into MVAB new is 50, MVAB old is 20. You simplify this value, the X per unit for generator 1 is equal to 0.5 per unit. So we have to use the calculator for simplifying these values. Similarly, we have to calculate the per unit reactance for transformer. So in this diagram, we'll have a component, that is generator 1, transformer 1, transmission line 1, transmission line 2, transformer 2, generator 2, transformer 3 and generator 3. Totally we have to calculate for 1, 2, 3, 4, 5, 6, 7, 8. 8 components we have to calculate. So now we have completed only for generator 1. Now we have to calculate for transformer 1. So the transformer 1 is 3-phase transformer. So we can take the value as it is. Reactance of transformer 1. Now the formula for transformer is this X per unit T1 equal to X per unit volt into kVb old divided by kVb new the whole square into MVAB new divided by MVAB old. For all the cases, we have to use this formula for all the component. Now, so the per unit reactance value of the transformer 1 is 0.1 to kVb volt. Here we can take the low voltage side. So for low voltage side, what is the reactance value of the transformer 1? That is 20 kV. Low voltage side of the transformer 1 is 20. Sorry, here it is in this problem not mentioned with the transformer 1 voltages. That is here we have to mention 220. 220 or 13.8 kV. That is the voltage level for transformer. Here they have mentioned with the only one voltage. We have to mention with the 220 bar 13.8 kV. So for this, the low voltage side of the transformer, the voltage is 13.8 kV. So that here we are taking low voltage side as a reference. So kVb old value is 13.8. The base value also 13.8. So 13.8 divided by 13.8 the whole square into MVAB new value is 300. What is the MVAB new value? MVAB new value of the transformer 1 is the transformer 1 is 50 and the MVAB old value of the transformer 1 is 20. So we have to substitute that 50 divided by 20. So we simplify this value. The X per unit new value for the transformer 1 become 0.2 per unit. Similarly, we have to calculate for reactance of the transmission line. So the reactance of the transmission line When we calculate the reactance for transmission line, we have to consider the voltage level. So the transmission line should be connected at high voltage side. So we have to go for the change in base voltage. So the formula for change in base kV is base kV on HT side is equal to base kV on LT side into HT voltage rating divided by LT voltage rating. So by using this formula, now we have to determine the new base kVA, sorry, base kV. So the new base kV on HT side is base kV on HT side equal to LT voltage rating, that is 13.8. HT voltage rating is 220 for transformer 1. The LT voltage rating is 13.8. If you simplify this, the base kV on HT side equal to 220 kV. Now, by using this new base kV, now we have to calculate the base impedance. So, the formula for base impedance is ZB equal to KVB squared divided by MVAB. So, ZB equal to, the KVB value is 220. So, 220 squared divided by new base MVA, that is 50. So the base impedance is ZB equal to 968 ohm. Now we have to determine the per unit value of the impedance of transformer. So X per unit transmission line 1 is equal to actual impedance by base impedance. Actual impedance is, that is 80 ohm, and the base impedance is 968 ohm. So X per unit transmission line 1 is equal to 0.0826 per unit. Similarly, the transmission line 2 also connected at high voltage side, but there is a changes only in impedance value. So the X per unit transmission line 2 is equal to, the impedance value for the section 2 is 100 ohm. So 100 divided by the base impedance is 968. So X per unit transmission line 2 is equal to 0.1033 per unit. Similarly, we have to go for the voltage conversion, because the transformer 2 we have to calculate the reactance, and for generator 2 we have to calculate the reactance. For transformer 2, either you can consider the high voltage side base voltage, or you can go for the base conversion. So now we will consider transformer to high voltage side. But in this case, what you have to do means, but transformer 2 is connected with the 3 single phase transformer connected for 3 phase operations. So we have to go for the voltage conversion on the star side. So for reactance of transformer 2, transformer 2, we have to go for the voltage conversion. That is, we have to write the condition. Transformer T2 is 3 single phase transformer connected for 3 phase operation. So we have to consider the transformer connection. So in the transformer connection, on high voltage side it is connected with the star connection. So in star connection the voltage will be different. In delta connection the voltage will be same. So that we have to go calculate the voltage rating. So voltage rating of 3 phase transformer equal to root 3 into 127. So we have to multiply the root 3 on star side. So it become approximately equal to 220 kilovolt. Now by using this value we can calculate the per unit reactance of the transformer. Now, so again the transformer 2 we can calculate on the low voltage side or high voltage side. Now we can go for the voltage conversion. It will be useful for calculating a reactance for generator 2. Now, so the base kV on LT side, LT side equal to base kV on HT side into LT voltage rating divided by HT voltage rating. So now, so base kV on HT side it become 220 and LT voltage rating is 18 and HT voltage rating of transformer is 220. So if we cancel this, the base kV on HT side, sorry, LT side, base kV on LT side equal to 18 kilovolt. By using this voltage, either you can calculate the reactance for transformer 2 or you can calculate the reactance for transform generator 2. So for transformer 2, we have to use the formula X per unit T2 is equal to X per unit volt into kVB volt divided by kVB nu the whole square into MVAB nu divided by MVAB volt. For transformer 2, the X per unit volt value is 0.1 and the kVB volt on low voltage side is 18 and the kVB new also 18. So 18 by 18 the whole square into MVAB new is 50. But for transformer 2 we should not take the power as it is. Here the transformer 2 is connected for 3 single phase transformer connected for 3 phase operation. So that here you have to take the power rating is the multiplication of 3 because we have to convert the single phase power into three phase power. So that if you simplify this values, we can determine the X per unit reactance for transformer 2. So if you simplify this, it becomes 0.1667 per unit. Similarly, we have to calculate the reactance for generator 2. So reactance of generator 2 by using the same formula. So we know that what is the formula for per unit reactance? X per unit mu is equal to X per unit volt. So the X per unit volt value of the generator 2 is 0.2 per unit, that is given in your problem, and the kVb old become 18 and the kVb new become 18. So 18 by 18 the whole square into MVAB new divided by MVAB old. MVAB new will be common for all the component and there will be the changes only in base voltages. If you simplify this, we can get the X per unit reactance of the generator 2 is 0.3333 per unit. Now we have to calculate the reactance for transformer 3. Reactance of transformer 3. Again, we have to go with the same formula. Now, the generator 3 is connected in low voltage side. So, again, we have to go with the voltage conversion. So, base kV on LT side is equal to base kV on HT side into LT voltage rating divided by HT voltage rating. So base kV on HT side is 220 kV, that is the last value which we have determined, and the LT voltage rating of the transformer 2 is 22 and the HT voltage rating is 220. If we simplify this, the base kV on HT side become 22 kV. Base kV on LT side equal to 22 kV. So by using this, we have to determine the transformer 3 per unit reactance and generator 3 per unit reactance. So X per unit transformer 3 is equal to the old value of the reactance is 0.1 and the kVb old value is 22 on low voltage side. The new value on the transformer 2 is 22 kV. So 22 divided by 22 the whole square into MVAB new 50, MVAB old is 35. So if you simplify this value, the X per unit transformer 3 become 0.1429 per unit. At last, we have to calculate the reactance for generator 3. Reactance of generator 3. So X per unit G3 equal to old value of the generator 3 is 0.2 and the voltage is 20. kVb old is 20, kVb new 22. So 20 divided by 22 the whole square into MVAB new is 50, MVAB old is 30. So if we simplify this, X per unit G3 equal to 0.2755 per unit. Now at last we have to draw the reactance diagram for the all reactance value based on the reactance which we got. So reactance diagram. How we can draw the reactance diagram means by taking single line diagram as a reference, then we have to calculate. For generator, we have to represent the each component with the per phase equivalent circuit. For the generator, the reactance should be connected in series with the generator EMF. Is EG1. So per unit reactance for the generator 1 is J0.5. So Xg1. Similarly, for transformer 1, that is X per unit T1 is J0.2. And for transmission line, the series reactance is J0.0826, which is connected at bus 1. Then for transmission line 2, this is X per unit TL1. X per unit TL2 is J0.1003, or we can write per unit. Now reactance of transformer 2 is J0.1667. This X per unit transformer 2, which is connected to the generator. The reactance of the generator 2 is X per unit G2 equal to J0.3333. Either you can represent in terms of J values, or you can represent in terms of per unit. So it becomes generated EMF EG2. Similarly, for transformer 3, the reactance value is X per unit transformer 3. It is J0.1429. At last, the generator 2, the reactance value is J0.2755. This is X per unit generator 3. The generator will have a generator EM. This is the per phase equivalent representation of all the components. So after determining the reactance value for each and every component, you have to represent in a per phase equivalent circuit. So this is the reactance diagram of the given single line diagram. Thank you.